Hi everyone, welcome to the next session of Geotechnical Engineering 2. In last class, we have discussed some problems on stability of slopes. We have discussed the stability of slopes for infinite slope as well as we have discussed for the stability of slope for finite slope. In today's class, we will see some more problems based on the analysis of stability of slopes for various type of conditions. In today's lecture, we'll discuss infinite slope, finite slope, as well as the standard method of slice condition. We'll discuss. If you observe here, I have written here one problem on standard method of slice. In this problem, they given the all contents. First, I am reading the problem. If you observe here, the problem is an embankment 10 meter high is inclined at an angle of 36 degrees to the horizontal. A stability analysis by the method of slices is given by the following force per running meter. That means here they gave the one embankment height as 10 meter as well as the embankment is having an inclination of 36 degrees to the horizontal. Again, if you observe here, they are given in problem itself the shearing force acting on the stability of the soil mass as 450 kN. That means this is the force that is trying to failuring the slope. That failuring of the slope of the soil mass they are given as 450 kN. Again, if you observe here, the normal force they are given in the problem itself as 900 kN. This normal force is the resistance force to sliding forces that they are giving as 900 kN. Again, if you observe here, they are given the neutral forces also. Neutral force means nothing but pore water pressure. In the slope, there is some development of pore water is there. Also, underground water is there. The underground water creating some pore water pressure or neutral pressure. That neutral force they are giving as 260 kN. Again, if you observe here, the length of the failure arc is 27 meter. Already we have discussed types of slope failures. In types of slope failures, we have discussed about the translation failure, rotation failure, compound failure, edge failure, like that. Various type of failures are there. Here they mention the length of the slope failure, how much distance the slope is failuring. That is, they are given this length of failure of the arc as 27 meter. Again, if you see here, laboratory test on the soil indicate the effective values of C and 5 as 20 kN per meter square as well as 18 degrees respectively. That means what is the embankment available here. For that embankment, they taken the soil and they conducted the laboratory experiment as direct shear test or triangular shear test. After conducting this experimentation, they got the values of shear strength parameters of soil C as 20 kN per meter square and angle of interflexion as phi equal to 18 degrees respectively. Now what they are asking me is they are asking determine the factor of safety of the slope with respect to the shear strength and as well as with respect to the cohesion. They are asking the factor of safety of the soil mass with respect to the shear strength as well as with respect to the cohesion. Already we have calculated the standard method of slices. In standard method of slices, we have considered one embankment, and in this embankment we are divided that to slope into number of slices. For each individual slice, we calculated the how much amount of normal force is acting, how much amount of shear force is acting. Again, if there is any pore water presence is there, how the slope is stable. For those conditions, we have calculated the factor of safety. If you observe here, stability analysis of slope for standard method of slice, we are using the factor of safety shear strength to the shear stress. We are using the formula C plus sigma n into tan phi by summation of tau. That means cohesion plus effective stress into tan phi divided by shear stress. That is the formula we have written. Okay. Before solving this problem, we will see what are the different types of parameters given in the problem. See, for while writing in your examination, you should have to write the figure itself. What is the problem they are given in the question, that you have to represent in a question format. That means suppose this is your horizontal ground surface. From this horizontal ground surface, the slope is, it will be like this, and the slope making an angle of inclination as, if you observe here, in slope it making an angle of inclination of 36 degrees to the horizontal. That means the slope is making 36 degrees to the horizontal. Again, if you observe here, this is the horizontal ground surface. In this horizontal ground surface, the length of the failure are given in the problem as 27 meters. The failure arc, it will be like this, and the length of the failure arc, it will be 27 meters. Again, if you observe here, they are given the experimental result value, cohesion and angle of intersection in the problem. That cohesion value C and angle of intersection phi value, they are given 20 kN per meter square and 18 degrees respectively. While writing in your examination, you should have to write all the parameters given in the problem. Before, this is the concept I have taken from textbook, but while writing in your examination, while preparing your notebook, you should have to write the given data. I am writing here first what is the given data. They are given in the problem. They are giving the cohesion of the soil mass. The cohesion of the soil mass they are given as 20 kilonewton per meter square. Cohesion of the soil mass equal to 20 kilonewton per meter square. As well as they are given the angle of intersection of the soil mass. That angle of intersection of the soil mass they are given as 18 degrees. That is 18 degrees. And again, if you observe here, the slope making an angle of inclination of 36 degrees, where beta equal to 36 degrees. This is slope making an angle of inclination with respect to the horizontal ground surface. And again, if you observe here, the length of the failure arc, that means if you consider this is your natural slope, the failure of the soil mass, it will be like this, and this length of the failure arc they are given as 27 meters. Okay, these are the data they are given in the problem. As well as for calculating, for analyzing the empirical values, we are considered this standard method of slice into different parts. While using for the standard method of slice, we have considered this finite slope or infinite slope, and we have divided this into number of slices, and for these each individual number of slices we have calculated the area of the wedge, we calculated the volume of the wedge, we calculated the how much amount of weight of force acting, how much amount of normal force acting, how much amount of shear force is acting, we are calculated. If you observe here in question itself, they given the normal force values, shear force values, as well as neutral forces values. That means if you observe here, from this in this slope, due to some external forces or due to some other forces or soil self weight itself, it causing the slope to failure. That means it is shearing the soil. That shearing of the soil they are given in the problem as the shear force of the soil they are given in the problem as 450 kilonewton. Otherwise, you can write these forces what they are given in the problem also. We can write summation of normal forces equal to, they are given in the normal force as 900 kilonewton, where normal force equal to 900 kilonewton, as well as summation of shear force equal to, shear force how much they are given? They are given problem shear force as 450 kilonewton. This is the shear force value they are given, as well as they are given the pore water pressure. That means nothing but pore water pressure we are representing as a summation of mu. That pore water pressure they are giving as 216 kilonewton force. This is the pore water pressure acting on the soil mass. Pore water pressure means the water what is in the underground, that is seepage into the slope. Due to this entering of the water to the top of the soil mass, the normal stress what is there, it will may leads to reducing the shear strength, which causes the slope to failure. Now if you observe here, factor of safety with respect to shear strength, by using standard method of slices, we are having the formula shear strength to the shear stresses, where shear strength is the value of S equal to C plus sigma n into tan phi, where shear strength S equal to C plus sigma n bar effective stress into tan phi, as well as where summation of tau is the shear stress value. So that shear stress value will be gamma z into cos I into sin phi. That previous condition we are discussed. Here where summation of tau is the shear stress value, they are given in the problem, where this is the shear stress value of the soil mass. Again, if you consider here C, where C is the cohesion of the soil mass presenting along this slope. That means throughout this length, this slope is having some amount of cohesion. That cohesion value we are taking it as capital C. Instead of capital C, we are representing C dash into r theta, where L equal to r into theta, That means length of the arc we are representing as the, suppose if you take this center of rotation, from the center of rotation to, we are considering this radius of the arc. If you take the center of rotation, it is making an angle theta. In some condition they are given in the problem, they will give the radius of this arc distance, they are given, as well as angle of center of rotation they will give. They will ask to find the length of the arc. In some conditions there also will be asked like that questions. That means length of the arc is directly they are given as 27 meters, but in some condition they will give the center of rotation theta value as well as radius of the arc they will give. In those conditions we have to calculate r into theta, where r is the radius of the arc, theta is the center of rotation. By calculating this formula, we can substitute this L value, length of the arc value, you may find out. And again, if you see here, where sigma n is the effective stress of the soil mass. Effective stress, it is the total stress minus pore water pressure, where effective stress sigma n bar equal to total stress minus pore water pressure, where here total stress is the summation of normal forces and where mu is the summation of pore water pressure. If you substitute C dash r theta, again effective stress, if you substitute summation of sigma minus summation of mu, that means normal force minus pore water pressure, then you will get the shear strength of the soil, where summation of T is the shear force. That means if you due to some self weight of the soil mass itself or due to some external force, the slope will may leads to failure of the soil mass. And again, if you see here, this is the formula we have derived from the shear strength and shear stress derivation. If you observe here, factor of safety Fs equal to C dash into r theta plus summation of effective stress into tan phi, where effective stress equal to total stress minus pore water. That means where summation of n is the normal force, that is the total stress, and mu is the pore water pressure, because there is some amount of water table present in the underground soil. The water is entering into the slope, which may leads to reducing the effective stress. Again, if you observe here, where summation of T is the shear force, that means it leads to failuring of the slope, that is given in the problem. And if you observe here, factor of safety of the soil mass Fs equal to, where C is the cohesion of the soil mass itself, they are given in the problem 20, and where 27 is the r theta, where r theta is the length of the arc. Again, you have to remember that in some condition they won't give this length of the arc equal to 27 meters. They will give the center of rotation theta as well as radius of the arc. In those conditions, you have to find out the length of the arc. Theta, it will be in degrees, you should have to convert into radians. That means that degrees divided by 180 into pi, if you substitute, you will get the values in terms of radians. And where plus CR theta we are substituted here, and plus summation of n, where n is the normal force acting on the soil mass. The normal force acting on the soil mass as 900 kilonewton. given in the problem as well as summation of mu. That means there is some amount of water table is present in the underground soil. The water table will enter into the top of the soil mass, which may leads to reduce the effective stress. That effective stress we have written here, and where tan phi is the angle of interfraction of the soil mass. That angle of interfraction given in the problem as 18 degrees. That means particle to particle interfraction, internal friction given in the problem as 18 degrees, divided by where summation of tau or summation of tau is the shear force acting on the soil mass. That shear force acting on the soil mass given in the problem itself as 450 kN. If you substitute all these values, and if you calculate the values, you will get this shear strength value as 1.70. This is the problem for stability analysis of standard method of slice for cohesive soil with respect to the shear strength. Okay, next we are having the factor of safety with respect to the cohesion. In previous condition we have considered only the factor of safety with respect to shear strength. In this condition they are asking to find the factor of safety with respect to cohesion. Already we are considered for factor of safety for different types of soil condition. If you check here, factor of safety of the soil mass with respect to cohesion, we are having C divided by Cm, as well as factor of safety with respect to angle of interfraction, we are having phi divided by phi m, as well as we are having factor of safety with respect to shear strength as S by tau. That means shear strength to the shear stresses. These are the three formulas we are considering for calculating the factor of safety. Here they are asking only to find out the factor of safety with respect to cohesion. That means what is there in previous condition. In that condition we are reducing the interfractional value, angle of interfraction value. That means if you deduct this normal force and shear force, see cohesion of the soil mass and length of the arc divided by shear stresses or shear force. If you substitute, we will get the factor of safety of the soil mass with respect to the cohesion. That means factor of safety with respect to cohesion, Fc equal to C dash r theta divided by summation of T. This is the formula for calculation of factor of safety with respect to cohesion, where Fc equal to C dash into r theta divided by summation of T. Again, from data given in the problem, where C dash is the cohesion of the soil mass given in the problem as 20 kN per meter square, and where r theta is the length of the arc given in the problem itself as 27, divided by where 450 is the shear force acting on the soil mass. If you substitute here factor of safety of the soil mass with respect to cohesion, we are having here 1.20. With respect to cohesion, if you see here the factor of safety value, it will be 1.20. Whereas if you consider factor of safety with respect to shear strength, we are having factor of safety as 1.70. That means the slope is stable, but compared to shear strength, compared to cohesion, with respect to shear strength, the slope is more stable compared to the individual cohesion of the soil mass. This is the problem how we have to solve for the standard method of slice using concept. Okay, this is the formulas. Okay, next we are having one more problem. This problem also we will discuss, and this problem number is 4. In last class we have discussed two more problems. This is problem number 4. Here this is the problem was asked by using Taylor stability number or Taylor stability chart. While discussing Taylor stability chart, I explained already that while asking the problems for any embankment or any finite slopes, they will give the stability chart towards to you, or they will give the stability value number in the question itself. If they are asking Taylor stability concept, they will definitely give the stability number, or you have to find out the stability number value by using charts. The charts they will provide in our examination if they are asking the question by using this concept. Okay. Next, this is the problem I am reading here again. The problem is an embankment is inclined an angle of 35 degrees and its height is 15 meter. What they are given here means an embankment is inclined at an angle of 35 degrees and its height is 15 meter. The angle of shearing resistance and cohesion intercept is 15 degrees as well as 200 kilonewton per meter square. Angle of shearing resistance, that means angle of intersection of the soil mass, how much it is having resistance, they are giving it as 15 degrees, particle to particle intersection, as well as cohesion intercept, particle to particle molecular force of interaction, they are giving as 200 kilonewton per meter square. Again, if you observe here, the unit weight of the soil is gamma equal to 18.0 kilonewton per meter cube. Here C they are given, as well as angle of intersection phi value they are given. Due to this C and phi, soil will get the strength. Due to cohesion as well as angle of intersection value, the unit weight of the soil mass also will get more value if you compact the soil. See, basically the soils, first the soil is in loosest state. If you compact the soil, due to this compactness, the air voids will may reduce. Due to this reducing of air voids, the density or unit weight of the soil mass will may increase. Due to increasing of this unit weight of the soil mass, the effective stress will may increase as well as permeability will may decrease. Due to increasing of this effective stress, bearing capacity value may increase. That means you can apply maximum amount of load. Due to maximum amount of bearing capacity, suppose you are constructing any footing, that footing cross section area we can reduce for that building. Due to reducing of this footing cross sectional area, the structure will make it economical. That means with less amount of cost, the structure we can make construct. Okay, that is the problem. And if you see here, the unit weight of the soil that given the problem itself as 18 kilonewton per meter cube. If the Taylor stability number is 0.06, Taylor stability number already we are discussed. It is represented by N or Sn. In some textbooks they will give it as N, and some others they will represent as Sn. The stability number they are given it as 0.06. And again, what they are asking means, they are asking find the factor of safety with respect to cohesion. Find the factor of safety. Again, they are asking find the factor of safety of the soil mass with respect to cohesion. With respect to cohesion, we are having the formula FOS equal to C divided by Cm. If while asking such type of questions, first you should have to know what are the different types of values that are given in the problem. Based on those problems, what are the various type of available formulas available for us, and based on the available formulas, we should have to calculate the factor of safety or cohesion or mobilized cohesion, okay, or the stability of the floor. And if you observe here, based on our stability number, we are having the formula where stability number or Taylor stability number Sn equal to C divided by gamma into Hc. This is the formula we are having for Taylor stability number. Again, if you observe here, they are asked the factor of safety with respect to cohesion. Factor of safety with respect to cohesion, we are having C divided by Cm. But in this condition, they are not given any type of factor of safety. They are given only the mobilized, they are given only the cohesion intercept as well as stability number C and phi value and gamma value. By using this concept, we have to calculate the mobilized cohesion of intercept. Based on that mobilized cohesion intercept, we have to calculate the factor of safety. If you observe here from this concept, already we have derived the stability number in terms of mobilized cohesion. If you observe here in terms of mobilized cohesion, we are having stability number Scm divided by gamma into capital H, where stability number Sn equal to C by gamma Hc, you can write it as Otherwise, Cm by gamma H, we can write it as how I am writing this means I am writing factor of safety with respect to critical height as H equal to Hc by H. Again, instead of H, I am writing H by F. Instead of H by M, we can write it as gamma into F. Okay, by C by gamma, we can substitute as Cm. This is the derivation already we have discussed in the Taylor stability number. Again, if you have any doubt, again go and check that point. And again, if you see here, there are given problems that are written here. And if you see here in this problem, what they are asked means they told that there is an earth embankment, and this earth embankment is making an angle of 35 degrees with the horizontal ground surface. It is better practice to write the diagram in our examination to give better results. And if you see here, where the angle of inclination slope making an angle of 35 degrees with respect to the horizontal ground surface. And again, if you observe here, this is the height of the embankment they are given in the problem. The height of the embankment is 15 meter. The horizontal angle of inclination of the ground surface will be beta equal to 35 degrees. And where phi is the angle of intersection of the soil mass, and C equal to cohesion intercept of the soil mass, C equal to 200 kilonewton per meter square. And gamma is the unit weight of the soil mass. The unit weight of the soil mass equal to gamma equal to 18.0 kilonewton per meter cube. Again, the Taylor stability number they are given in the problem as n equal to 0.006. This Taylor stability number we can write it as n or Sn. If you see here, otherwise again we will derive this problem. Taylor stability number we are having the formula. Sn equal to C divided by gamma into Hc. This is the formula we have to remember. Again, if you see here, factor of safety with respect to cohesion, we are having C divided by Cm. Now my interest is to find out the Cm. And again, if you see factor of safety with respect to critical height, we are having Hc divided by H. Factor of safety with respect to critical height, we are having Hc divided by critical height to the Hc divided by H. From this critical height, based on these derivations, and if you substitute C by gamma Hc from Taylor stability number, we are having the Taylor stability number in terms of mobilized cohesion intercept. We are having the Taylor stability number n equal to Cm by gamma into H, where n is the Taylor stability number, Cm is the mobilized cohesion intercept, and gamma is the unit weight of the soil mass, and capital H is the height of the embankment. Now I want to calculate the mobilized cohesion value. That means mobilized cohesion value Cm equal to n into gamma into H, where n is the Taylor stability number. That means 0.06 into gamma is the unit weight of the soil mass 15 into unit weight of the soil mass into where H is the height of the embankment. If you substitute, you will get the mobilized cohesion intercept of the soil mass. That mobilized cohesion intercept of the soil mass, we are deriving stability number, unit weight, and the height of the embankment. We are getting the mobilized cohesion intercept Cm equal to 16.2 kilonewton per meter square. Again, from this concept, we are having the factor of safety with respect to cohesion. Already we know the factor of safety with respect to cohesion. We are having the formula for C divided by Cm, where C is the cohesion of the soil mass 200 kN per meter square. Cm is the mobilized cohesion intercept, that it will be 16.2 into kilonewton per meter square. If you substitute C divided by Cm, you will get the factor of safety with respect to cohesion of the soil mass. If you observe here, where cohesion strength or cohesion intercept of the soil mass C equal to 200 kilonewton per meter square, and factor of safety with respect to friction, we are having factor of safety with respect to friction equal to C divided by Cm, where C is the they are given in the problem cohesion intercept as 200, and where Cm is the mobilized cohesion intercept. Mobilized cohesion intercept means the 200 kilonewton per meter square. What is there due to this external forces or due to the sliding force? The friction what is there, it will somewhat reduce. That reducing mobilized cohesion we are taking it as 16.2, and if you observe here the factor of safety we are having 12.3. that means it is having greater than 1, hence why this slope is stable for this type of soil condition. Up to now this is the problem for stability analysis of slopes by using Taylor stability number. Okay, this is the concept. In later class we will discuss about the somewhat problems, stability analysis of slope for finite slope in terms of cohesive soil as well as cohesionless soil, when there is soil mass is in dry condition, or when the soil mass is in steady surface condition, or when the soil mass is in submerged condition. We will discuss in our next class. Thank you.